Unfortunately, none of these are quite for sale, are they, Ollie? And he's counted them, and he wants them all back.
A lot of them are scrap, by the way.
Okay. I'm trying to build them up.
I have to say, you're quite an intimidating audience. There's so much Bristol knowledge here. You know, and I'm only 36, so I'm a ways behind most of you.
Just a kid.
Yeah, I am just a kid. And my father should have really done this talk, but he's testing at Silverstone today. So you've got me as I've been delegated to come and talk to you. So I thought, what could I bring that you've probably not all seen before? Because most of you own very nice Bristols, some of you more than one. And I thought I'd start with the 85 series head, the very early head. Now, I don't actually have a very early head. I've heard, some of you will correct me, that Bristol used 2 different foundries at the beginning, and the early heads were not very good, and most of them corroded away. Andy, is that correct? So I've never actually seen a very early head. Presumably they're all gone.
The number of 400 heads had to be exchanged by the factory.
Did they? Yeah.
In the first year or two, even.
Even, yeah. And the earliest head we have here is an 85A head. This carburetor over here, it was made, is a Solex, Solex twin choke Solex, 30 PAAI, or sometimes known as an AAPI. It was used on a Ford V8 Pilot after the war. And the Pilot, the biggest engine the Pilot had was a 3.6 litre V8. Same carb on a Bristol, produced 75 horsepower. Same engine, the Ford V8, which was side valve, produced about 80 horsepower. So that shows you how good the Bristol engine was straight away. It's a lot more efficient engine. Yeah, I'd never seen that setup, that inlet manifold, until I started rummaging boxes at Brian May's auction. Show of hands, who bid on something at Brian May's? Did anybody see that for sale? No. It was in the bottom of a box. It was just a load of rubbish, and in the bottom was that manifold and that carb. And I thought, I've never seen one of those, only in a book. I think Chris Balfour's book has a photo of an 85A block with a head, with one of those carbs, with one of those manifolds.
85, it's a single carb.
Yeah, sorry, technically 85, yeah. Is that yours? Did you, where was the photo? Fabulous.
In the back garden.
In your back garden?
Yeah.
So you've still got one of those, have you? And you've got the special air filter cleaner setup on top of it.
Yes, it's the standard collector, but then you've got the square versus the square air cleaner.
Yeah, on the top. And is that magnesium cast?
No,
is it aluminium?
Yeah.
So I've never seen one of those either.
I've only seen one at a concours many years ago, other than mine.
Well, you were my inspiration for buying that Prime Maze auction. So there's a gem in the bottom of this box.
It runs very smoothly.
Does it?
Yeah.
I would love to have a go one day with a car with one of those on. Never driven one. That manifold is dated 6/6/47. It's stamped in it. So presumably that's when it passed inspection at Bristol. Bristol were really hot on, because of the aircraft manufacturers, inspecting every item. And nearly every aluminium thing has got an inspection stamp on it, which is very small, about this big, and it says BACD. You'll see it on some of the heads. When we turn over some heads in a bit, when at lunch, you can have a little wander around. Because Bristol, when they inspected each cylinder, they put a stamp on in each one to show that they'd inspected it. Yeah, you'll see them here. They're actually there. So you've got 1, 2, 3, 4, 5, 6, and then a stamp next to each cylinder to show that it had been inspected. So it's great that somebody's actually here that's driven one of these setups, because I haven't. What's very interesting about it is there's a restrictor plate. Has yours got that, Chris, in it? There's a restrictor plate here in the manifold.
No, don't think it has.
Well, we should take it apart, me and you, in a bit. And it's shaped like this, and it's very restricted.
I don't think I've got that on mine. Don't remember it.
I wonder if that was a later mod or something they trialled maybe. Let's just whip the manifold off, because I've only put it on lightly. just so everyone can have a look. So this is an 85A head, kindly lent to me by Tony Byford and Roddy McPherson. It is, but I don't actually have. We'll take this off, and it will suddenly become an 85A with a balance tube in it. Strictly, these carbs should have been on this head, but I ran out of time. Right, everyone can have a good look at that later. So 85A heads, all with the balance tube for the SUs. I quite like the SU setup. It seems a bit bonkers, this whole choke system. So you've got a manual choke and also this solenoid operated choke as well. So every 400's got that carb pull switch in the dash, which obviously not many people use anymore because a lot of them have got Solexes on. So 85A head, not very big valves. So 36mm inlet valves, and this is quite a flat head. We were talking about flat heads earlier. When you start to lose all the detail underneath the cylinder head, that's when they start to become quite flat. Although it can be really misleading because some of the heads, when they were cast, they look like they're cast on a slant, but they're not. So if you check the depths of the actual combustion chambers, and our combustion chamber depth expert is Roddy McPherson at the back, who knows them all off his head. Tell you, Roddy. Yeah. So Roddy could tell us the depth of an 85A combustion chamber from new and how that differs from, let's say, 100D depth. One of the cheapest and easiest ways to raise compression at Bristol's was just to skim the heads more. You know, it was more expensive to have lots of different piston designs. So yeah, 85A head. Yeah, pretty high efficiency. Not massive great advance on BMW's pre-war design though. BMW before the war, in their racing engines, were already getting 130 horsepower in the Mealy engines, and they tried bigger valves than this already. So that's quite interesting. Peak power, about 4.2 to 4.5. This head actually has already been converted to run on Solex carburetors. So Bristol, I think Bristol did this at the factory. Andy might correct me. They put a sleeve in here to get rid of the balance tube. So you can no longer get the balance tube. You can get my finger in there and in here, but not here to run.
Was the balance tube more for to equilibrate the vacuum, or do you think it was mixture?
I think mixture. It could have been a bit of both though. Yeah, I mean, so if you think about before the war, BMW, they didn't cast a balance tube in, but they had it between the inlet manifolds. So there is that's how they did it. They did it slightly differently. I really like the 34 ICHs. They look a bit modern. The only problem with them are they've got a fixed choke, the Webers. So when you buy the bodies, they're either 25, 27 or 29mm chokes. Whereas obviously with the Solexes, you can take the chokes out and change them for whatever you like. Although you can't get bigger than about 29s in. Not that you'd want to. Most of the racing cars that we run have 27 or 28mm chokes in. So we'll put this one back. That was the 85A. Thanks, Roddy, for lending that one. It's had a bit of a tough life, that one. So this is actually a 100A head. So totally different casting. But before we get onto this, we should talk about the 85 B and C. The early 85C engines in the 401s, I think I'm right in saying, obviously had quite a lot of these castings left over. So they sleeved them, and all the early 401s would have had a head that looks like this, with the sleeve, with the Solexes on though. Slightly more power, 85 horsepower, I think, like that. Yeah, so they had to use them up, I suppose. So, you know, they made 450 400s, something like that. Somebody will know the exact number. And then they sold well over 600 401s. So, I think all the early 401s would have had this type. And then moving on to not having the balance tube casting. You can maybe see that the inlet manifolds, the inlets are quite Siamese, like this. And I think that helps swirl. I think that was well, it was done deliberately. They only have one flat at the front here, which could have been used for vacuum, but obviously they weren't fitted with servos, so I think that's what this pipe was for, was to go on there. The later heads differ in that they all have flats, the very late heads from like all the 110 series, all the 100 D2s nearly, all have flats on here, which you'll see on that head. And those flats were used in the 110 series for the servo, for the vacuum for the servo. That's one way to spot a 110 series head from a mile off, is that every single one of those bosses is drilled and tapped. So you can see the flat. It's going to be difficult to see from the back, but there's a flat there, there's a flat there, and a flat there. And this has only got the front one drilled and tapped, because this was off this is a 100D head, an early 100D head. But yeah, 110 series, all of those. Now, I'm pretty sure the 110 series head.
Put the lights on there.
Can we?
Some lights there might help.
Yeah, but everyone can have a mill round afterwards anyway. I'm pretty sure the casting was exactly the same for the 110 series, just machined differently. That's the same for us in racing. We get these castings, and we've developed a 2.4 engine using this same casting. So it's the same casting as a 2 litre, and all we do is machine it differently. So we offset the combustion chamber. So this chamber comes like this one like this. The spark plug and valve stay exactly in the same place. But there's enough meat here to do that. And it gives you 2,452 cc, which is quite interesting. The bores in the block are obviously offset as well. We don't use liners in the block because of modern metal, basically. You can liner the blocks if you want. And in fact, if they were to wear, that would be the best thing to do. It would just be to overbore and liner them. Not for the 2.4 engine, that's for the 2 litre blocks. So yeah, this has been something we've spent years developing now.
What size do the valves wind up? Obviously that's a casting and hasn't been machined at all yet.
So, good question. So obviously Bristol used a 39mm and sometimes slightly more than 39mm valve. I don't think they ever went to 40, 39 point something for the inlets. Our biggest valve's 41.8mm for the inlets. It's also a lightened valve, so it's got a thinner stem. We lighten the valve train to get more RPM. But that's the main reason for having a light valve train. Sorry. Higher RPM comes more power. Lightening the valve train, very important. We also changed the design of the collets. So the collets are a groove design, which is a modern design, versus the old design, which is like more of a wedge, 2 wedges. Bristol claimed, and in the Setright book, it says that this head produced 170 horsepower at 7,000 RPM. Now, I'm dubious about that, because if you rev the normal collet design to 7,000 RPM, you will drop a valve. I'll guarantee it. I grew up watching Ronnie McPherson race Keith Bristols, and a bit of an idol of mine over there. And Roddy never used to exceed, 6,000? Yeah, and you can have a very reliable racing engine using the original collet design with a 6,000 limit. So our modern racing engines can go to 7,000, but that's because of the lighter weight valves, because of titanium valve spring top caps. Not a lot more spring pressure. We don't have really high spring pressures. Really high spring pressures will ruin your cam and cam followers quite quickly. So not only will they ruin your followers and your cam, they also zap power out the engine. So really you want the lightest spring you can have without the valves floating at the RPM that you want. Now I think this engine, could they have revved to 7,000, the BSX or the BC head, could they have revved to 7,000 reliably in period? I think that would have been a really cool thing, because this breathes so much better, really, really well. With this design, this is still a good design though, with the 3 carbs, and we're able to actually get more power out of this now than you could get out of that in period, which is interesting. In the workshop over the years, haven't seen very many cars with 6-port heads, I have to say. Warwick Banks is 404. Tony Bancroft's AC Ace, Bristol. These heads, this is a late 53 head, this one. So a very early 6-port Bristol head. They changed the design a few times. They ended up, if you got the set right book, with a single bar going across. Special Solex carburetors, sandcast, which I don't have. Twin chokes, only made for the Le Mans cars. Be nice to reunite that head with some of them, but they're like hen's teeth. Yeah, so we're able to get slightly more power out of this. These heads were designed just for Le Mans, to go flat out down the Mulsanne straight, hour after hour after hour. They weren't designed for pulling away from the traffic lights, you know, outside B&Q. Jeff Dowdall in Australia has created his own 6-port head, which is amazing, you know, what a guy. But he's found, I think he's put Webers on his, he's found that to make it nice on the street, you need very small chokes in the Webers, because at low RPM, you don't have the airspeed with the big chokes, and it doesn't want to pull away at all. So putting really small chokes kind of, for me, kind of negates the fact of having this really free-breathing head. And I think he's got 140-ish horsepower out of his 130, something like that. But a really cool engineering challenge, and he did it by modifying an original head, which is something that Bob Gerard did in period, Rod Speed did in period, maybe Barwell, I think. Was that right, Roddy? Yeah, I'm getting it. And Westlake. But I think Harry Westlake also had something to do with this design as well. He was contracted in by Bristol to help get more power out of it. I think what's also a really key thing for the 6-port head at Le Mans is that the fuel was rubbish at Le Mans. It still is. It still is. Only place where we've had a head gasket failure for years is at Le Mans, and you have to use the fuel that they provide, and the fuel's crap. So I think that's why. We didn't actually run any higher compression in these racing cylinder heads than Bristol did in period. So some of the BS4 heads in period ran at 11:1 compression. We don't go any higher than that. So the more power is just in the shape of the inlet tracks, which when Peter designed the head, they're slightly different. You see, they're much straighter. Can everyone see that? They're much straighter in the new head than they were originally. So maybe not for the purists, but I guess if you're going to go to all the expense and time of designing something, Peter worked very closely with Cosworth for many, many years, Peter J. And when I last went to see him, he was machining some DFV blocks as one of his last jobs for Richardson's. So yeah, a nice idea, less swirl like this, I think. We don't open out the ports too much. If you open them out again, you don't get such good torque. The car doesn't want to pull away. You know, you don't want a racing engine that only works between 6 and 6,500. You want something that's really tractable from sort of 3 at least. 3 to, although we have developed some new cam designs. So our latest cam is better sort of 4 to 6.5. It starts to run out of puff after 6,500. So that's what's nice about having the 7,000 limit, because if you miss a gear, the valves aren't gonna hit the pistons, and it all gets very expensive very quickly if you're not careful. So that's this one. Any questions about the new ones?
What sort of power are you getting out of the 2.4?
I don't know, Jeffrey, is the answer. So I have run it on the engine stand at work, and I've run it in a car last year, and I've yet to put it I'd like to take it out and send it to an independent dyno, engine dyno. That's the best thing to do. I think people that own their own dynos and dyno their own engines, you can sort of make it give you what you want. The thing about a power meter is, the crucial thing about a power meter is that it registers the same every day. So it doesn't matter if it registers 50, as long as it registers 50 horsepower every day. And if you make a modification to the air-fuel ratio and you get more power, then you get 51, that's great, isn't it? You know, it could be 51, it could be 151. You just need to know whether you're going the right way or the wrong way. So we build a lot of engines, and obviously a lot of people want independent valuation. We use Atwell-Wilson at Leicester, and Sam and his dad that have been going for many, many years, quite famous for doing Ferrari restorations and Ferrari P4 replicas. So they independently dyno our engines. So the answer is I don't know. I think the 2.4 will give a lot more torque. And it might not give a huge amount more power. So we'll see. I mean, we see that in the 110 series in a Bristol. So the 2.2 engine in Bristol's gave the same 105 brake horsepower as the 100 B2, but the torque was better and at lower RPM. So you got more torque at 3,000, whereas peak torque on the 100 B2 was near 3,750, I think. So we're hoping for more torque, and touch wood, it's got to give more torque. It's got such bigger pistons in it. It's just how it will burn. It will be interesting. So because it's all offset, the piston isn't a fancy anything super fancy. It's quite a conservative design really, and we haven't gone for high compression. So I'm hoping for a lot more torque. It'd be nice to have 200 horsepower. Never seen it. So the most I've ever seen a 2-litre Bristol produce is 185 horsepower at the flywheel. That's really reaching the capabilities of what's possible. I think to get a lot more power, what are the cheaty options? 67mm pistons are an easy way of doing it, which we don't actually make it in racing. So there you go. Can't accuse us of cheating because we don't actually stock a 67mm piston or make one. The other way is to try and use a 2.2 crank, so 99mm stroke cranks. But if you use a 67mm piston and a 99mm stroke crank, which is exactly the same stroke as Bristol used in a 110 series engine, you only end up with like 2.1. So slightly more power. Maybe you could go 180 to 190. I don't know. You've got a very long stroke in a Bristol versus the width of the piston. So I can't see us getting a lot more out of them reliably anyway. I mean, Mike Hawthorne and Leslie Hawthorne, his dad, got quite a lot of horsepower out of a Bristol in period, running on nitro and methanol with nitro in it. But I read that Leslie would strip down the engine after every single race and rebuild the whole thing. So you need deep pockets for something like that. You know, our race engine should easily do 3 or 4 seasons. We're not pulling them apart after every race. Yeah, absolutely not. And I think our customers would be, if I told them that, they would have a fit. But yeah, I mean, if you look at mini engines now, racing mini engines from Nick Swift, brilliant engineer, amazing engines, but you're meant to send them back after 10 hours. Now, 10 hours isn't a lot of driving, is it, on a racing circuit and testing? So, but they are revving them to sort of, I don't know, 8,500 now or something daft. Yeah, amazing things. But with the Bristol engine, it's what's really nice about it is the fact it should be quite reliable, because it's a road engine made into a racing engine. It's not a race. It wasn't built just as a racing engine. I think on the road, there's never any point having more than about 140 to 150 horsepower. You can't drive at 6,000 RPM all the time, and total waste of time really. The really nice camshaft that we recommend is Bristol's own camshaft. So Bristol did the what we call the 590 cam, which is the Bristol sports cam, is fitted as standard to all AC Aces and things like that. But it's a nice sports cam, and with electronic ignition, you can get it to pull really lovely from about 1500 RPM. And that's the mildest cam we now sell because it fits inside the standard journals. You don't have to modify your block in any way, your camshaft journals. Obviously, the fancier cams are higher lift, so to get them in, you need to alter the cam bearings. And it starts to become really expensive, and for most road cars, total waste of time. I wouldn't particularly recommend having, super high lift stuff because they're quite heavy cars, aren't they, Bristols? You need to get them moving. So you need the torque, and you don't want to be having to rev it high to move it.
What power are you getting on your Cooper Bristol engines?
Yeah, between 175 and 185.
And that's just standard, is it? I mean, all of them are doing 175 to 185.
Yeah. You can't.
And lasting for 3 or 4 seasons.
Yeah. You can't build one for one customer better than another customer. Everybody's quite similar. Obviously, we're always trying to make them a bit quicker, and a lot of that is very small little developments, and a lot of them aren't really worth it. Most people can't tell a difference. If 10 horsepower between one engine and another, I can't tell a difference. Driving the car, I can't tell a difference. You need to be like Nicky Lauda to notice the difference of 10 horsepower difference. What we try and do is have something that's very tractable that doesn't just work at high RPM. You do get a lot of standoff on these carbs though with our race cams. We do alter the carburetors a lot. The Solexes get altered a lot to try and make them work better, but they doesn't make a huge difference. We have trumpets and integrated chokes, and another big thing is making sure if they flood, they flood down into the carb and not out of the carb, because some people used to develop funnels that covered that, and then they used to catch fire a lot. I think owning a Bristol, you will all tell me that the first thing you do after you've left it for the winter is to check to make sure there's no fuel leaks out of those banjos, because the fibre washers dry out and then it's want to catch fire. So it's something I check in every car I get in. Often we remove those, and have a feed to each carb, separate feed to each carburetor, which I think for the full racing cars is worth it, because then obviously the fuel doesn't have to go by one to the next one to the next one. But again, for a road car, no, absolutely not. And the fuel pump, the standard fuel pump's more than man enough to, electric fuel pumps. I think electric fuel pumps often create more problems than they solve, really. Because you can have too much fuel then, and it's easy to flood it, and blah, blah, blah. I think the mechanical fuel pumps, provided it's got one of, it's been rebuilt nicely, is a good thing. The interesting thing about the fuel pumps is the 2.2 pump's different from the 2-litre pump, which is unusual. It's got a different arm in it, presumably to pump a bit more fuel, so more leverage. But that was another thing that I bought at the Brian May auction, was trying to find one of those pumps because they're difficult to find. But if you're going to build a 110 series engine, you do need one of those, really. Yeah. Any questions about making Bristols go fast or racing them? Or
Why did Bristol change from the SU to the Solex then?
More power, I think.
Yeah.
They were after more power. Yeah, I think that's the main reason. These are only an inch and an eighth downdraft SUs, so they're not very big. No. You very rarely see these cars, by the way. If you ever try and buy some at Auto Trumples, they're a specially made downdraft SU called a D2. They've got this little oiler at the top. That's your dead giveaway. They were fitted on quite a few cars before the war, like Singers, not a standard though, Austin 7s. I spent years trying to buy a set for a car. Yeah,
it was done by Western Services in Kingsland Road.
Is that right?
They were involved in the development of fitting the Solex.
Of fitting the Solexes.
But they never told me why.
Why? I think it was more power.
Yeah.
That's the only thing I can think of. more
One other thing,
more
what
power.
plugs do you run in them?
NGKs.
You
Yeah,
do? 'Cause
yeah.
I put NGKs into my 405.
Yeah.
I must admit they got fouled because it was burning oil badly initially. But I found it runs better on an old set of KLGs that I bought from Bristol Cars in 1973.
Which NGKs were you running? Because there's a lot of different NGKs you can put in a Bristol.
I don't remember.
Okay. One of the problems with plugs were they couldn't operate over a wide range of temperatures, which is why back in the 70s, 80s, you'd start the car on one set of plugs and race it on another set of plugs. But it's come on so much, plugs. And NGKs, for a road car, we normally recommend C5 or a C6 HSA. They're a really good plug, and inexpensive to buy as well. Very inexpensive. Just make sure you gap it.
When I go down to the local motorbike dealer to buy a set of 6, I get great respect as they wonder what I'm
Yeah, what you're going to put them? What exactly are you going to put them in? Exactly. Yeah. The only annoying thing about the modern plugs is you can't use your lovely Bristol plug spanner in them without modifying it.
Coming back to the early days, of course we only had pool petrol for, well, every 400 would have performed and given its performance figures on pool petrol and many 401s, because when did pool petrol end? It was 52, 53, does anybody know?
Yeah, maybe 54 might be the
So
last.
getting those performance figures on 80 octane.
Amazing. Yeah. Yeah, hence the low compression of 7.5.
Yes.
And then 8.5, and then in the 100D, 9.5 to 1. Yeah, modern fuel, again, apart from the ethanol bit aside, is a lot better. So if for fast road use, we generally have about 10 to 1 compression, generally, and you're absolutely fine to fill it up with pump. I mean, I recommend just using 99 octane with the E5. For the racing cars at 11 to 1, we tend to use 105 octane racing fuel, leaded racing fuel, which is horrendously expensive from Sonoco. So yeah, again, not necessary, just normal super leaded, absolutely fine. And that's where the performance gains come. So if you take a tired 100D engine, you know, when it was new, it was meant to produce 125-ish, 128 horsepower, something like that. But they were made on a budget, the 100D engines. You know, they were made for AC cars. They weren't like the BS engines. They were sort of a budget copy of a BS engine. So they weren't all hand-finished in the ports and nicely. They were just sort of thrown together. The reason that they had more compression is just they skimmed the heads a bit more. Yeah, so they weren't. People think, oh, 100D engine is the one to have, but you know, any of the 100 series heads you can fit the 39mm valves in. So a 100A head, you know, for me is just as good as a 100D head. You can make them go just as quickly. So yeah, it's not some. I mean, the ones that are a bit more tricky is the 110 series, because they're so deep and they're machined so wide to accept each combustion chamber to accept the 69mm piston. That's a bit difficult because you can't get 69mm pistons anymore. So we normally either weld up the heads to take 67mm piston, or if you skim them quite heavily, the landings between the combustion chambers gets thicker, and then you can fit a 2-litre head gasket on. And if you've already sleeved the engine down 6-7mm pistons, away you go. And 6-7mm pistons for the original conrods are available through Roddy, Cosworth, lovely pistons, lovely forged pistons. Yeah, so, I mean, I remember a time where I had never seen a 110 series engine come into the workshop, and then 3 or 4 years ago, 3 or 4 came in all at once to be rebuilt. So, yeah, I think the next thing we really need to do is have 2.2-litre head gaskets made new, because I don't know of availability of those at the moment. Cometic made some. There was some left over, some old. Is it Payan? Payan gets some, yeah, but Payan. But there's none that I know of anymore, which is not good for the people that own original 2.2s. So yeah, we should invest having some more made. I invested quite heavily having the 2.4s made though. You can't order just 10 gaskets. I think I had to order 50 or 100. There's only one engine of this engine running in the world. Same with the pistons. I think I ordered 30, 40 odd pistons. And again, there's only 6 in a car. So it represents a huge investment for the business. Yeah, we'll see. We'll see how it goes. I mean, I think it should go well. But.
Any more questions, guys?
Yeah.
Exhaust, if I could.
Yeah, go for it. Exhaust.
I can't remember who, somebody saying a while ago that you could, possibly separate, postulating twin exhaust on a 2 litre, so rather than combining the 2 downpipes. Any thoughts on that?
Yeah.
How do you do
Yeah, good.
difference?
Something that nearly all Coupe Bristols are like that. So you've got 3 into 1, 2 3-into-1s, and they never join. Yeah, so
Effectively using a V8 exhaust system on a 6-cylinder.
on a 6-cylinder,
Yeah.
if you remember the 450, the 450, they tried lots of similar things like that. They tried 2-into-1s and then not joining together. But in the end, in 55, they joined them all into 1 and got 8 more horsepower. The back pressure's affected. The other thing that was, if anybody's read the Jennings book, is it R. Jennings, wrote a fabulous book about his time working at Fraser Nash, AFN Limited in 51. If anyone's never read that, you should try and get a copy because he was a fascinating guy. He ran the engine brake at AFN Limited, and he didn't have very nice things to say about Bristol's sports department. He thought they were a bunch of cowboys, and he didn't rate their work at all. And he used to rebuild the engines before they went into Fraser Nash's. So there's one copy on eBay. You should all go and get it. I'll go and get it. I've got a few copies I could probably, if anybody wants one. I think Roddy's also got a few copies. But yeah, they tried lots of different exhaust systems. Jennings actually calculated in 51 that they could do with a much longer primary. So, and he said that they were working so hard, nobody got round to it. But he worked out that the primary length needed to be like doubled or tripled versus what it already was. This is one of the limitations. The exhaust is a huge limitation to a standard Bristol 2 litre because you've got the cast manifolds, which are 3-into-1, and those primaries are not very long at all. Not very long at all. And it was the same on a BMW 328 because they had a similar-ish manifold to that, 3-into-1, and then those 2s went into 1, and how that happens can make a big difference in the power. So what we see with exhaust is you can give an engine maybe 10-to-1 has 130 horsepower. If you give it 11-to-1 compression, it won't necessarily have any more horsepower. If you don't alter the exhaust system, if it can't scavenge well, you won't get any more power. So the exhaust is key. The long primaries give you more torque as well. Last weekend, just gone, in racing, Bristol engines came 1st and 3rd in the Parnell Cup, which was good for Bristols, I guess, in Cooper Bristols. And both of those engines have what you've described, Chris. So 3-into-1s with quite long primaries, and then single pipes of equal length, which terminate in front of the rear wheel.
So is there a payoff at lower levels? Do you lose on torque?
No, you don't. No, you gain on torque. You gain everywhere, actually. And another thing that you gain is if you don't have a silencer in it. So in an ACA Bristol, we took a silencer off one recently and gained 7 more horsepower on the rolling range straight away. So that's a big old lump of horsepower, isn't it? Just for one thing. So you think about it, you take the silencer off, you take the fan off the front of the water pump, that's a half a horsepower or something daft. You take the fuel pump off, there's lots of ways of these marginal gains add up to more power. Bristol famously knife-edged the butterflies inside the Solexes and inside the Le Mans engines as well. We don't do that because, for several reasons. One, those butterflies have a nice 8-degree on them, and it seals really nicely. Without that, they don't seal very nicely, and you get a crappy idle. Also, if you knife edge them, they can start to bite into the castings, which is not good. You know, that's the sort of thing that if you're rebuilding the engine a lot, maybe it's worth doing. What we do instead is have a very, very low profile split spindle for racing engines, a very low profile spindle that we make in Nottingham. Most of the stuff we make in Nottingham. Yeah, and that's the only difference, with special, very small screws to hold it in. So we don't knife edge them, but we do have a very low profile thing. We also sometimes waste away the emulsion tube holders and all sorts of things like that to try and get better flow through it. In the full racing engines, we run 34mm butterflies as well, not 32mm. So we bore out the base of the carbs and run 34mm. Again, this is a waste of time on the road, really. You know, you're only seeing the difference on those carbs, 6,000, 6.5. So, you know, total waste time if you're not going to be running that. You can get 175 horsepower with the 32mm butterflies. So, yeah, not something I recommend. It's all just the tiny bits that take ages and don't really give you a lot more power. Yeah. Any more questions?
Yeah, you say you can machine one of your new blocks for a 110. I understand that the camshaft housings on the 110 are offset to the 100.
Yeah, that's correct.
And a 100 series fuel pump won't fit.
Yeah.
How do you get around that?
Yeah, so you're quite right. So a 2.2 litre Bristol 110 series uses a unique cam that is not like any other cam. They use different followers as well. So the actual follower housings are a different size as well.
And can you supply the follower? Yeah, they are a different size.
They are a different size. Yes, you can. So the trick there is they're same as a mini follower, the same size as a mini follower. So with a very light hone, you can fit mini followers in, A series. And all of our camshafts are made by RS Piper, billet camshafts. And Piper sell a follower to match the cam. And they have an oil hole in them, which is good. It's good to have an oil hole in them. And that's what I do. So if I'm trying to rebuild a 110, I can't get that original cam. So we normally fit a 2 litre cam. So we put fit 2 litre cam in it, and then do what I've just described. Yeah, yeah.
And what do you fit a 100 series petrol pump?
Yes, you could do in that respect. Yeah, yeah.
Because the 100 series won't fit.
No, it's the arm is not. The arm is different in the pump.
I think the location's different as well. Because I think Bristol's had a new casting. I don't think it's the old casting.
I don't. I've got 2 110 series engines sat on a bench at work, and I think it's in the same place, but the lobe might be different on the cam, and the arm is different for sure in the AC Delco lift pump, and I think that was to give more fuel. If you remember the Vaux air filters, Ronnie McPherson did some tests with the Vaux air filters, and they're a specific height, the air filter. And he found that the 2.2 litre required a higher Vaux filter. It required to move because it was sucking in more air, basically. And if you use the standard Vaux height, that was limiting on the 2.2, higher RPM. So, yeah, they are a bit different, and they are rare. They didn't make very many of the 2.2 engines. Hence, we rarely see them. But they're a nice thing. I think, you know, in period they had a little bit of a reputation of having head gasket issues and things. But because the lands were they were so small. And what's interesting about us doing the 2.4, we didn't want that. We didn't want small lands between I've got my fingers trapped in it, there we go. So we've kept the landings in the 2.4 exactly the same as the 2 litre. Because we didn't want to have these problems with the head gasket. So by offsetting the bores, we managed to keep that exactly the same size as the 2 litre in our 2.4. Yeah, and with modern head gaskets, modern composite head gaskets like you can get from Spencer Lane Jones stock a good one, we stock a good one. Very identical price to each other, but they're equally as good. With good modern composite head gaskets and with good head studs. So the Bristol head studs, you can get much better quality studs now. They stretched a bit, and the nuts used to break. The nuts are kind of made of cheese You take them on and off a few times. So yeah, we use a motorbike nut on ours. And the sorry? No, they're not.
TT Workshops went up to 13 mil, which was a pain because you had to make up a new spanner for it.
Well, so don't worry, I'll sell the spanner. So ours are a 1/2-inch AF with a 12-point nut. Yeah, with a 12-point nut, and obviously all threaded right at the end of the block. The studs are made in the UK, and they're rolled. They're made out of an aircraft spec steel, which makes them expensive, but they are really good. And again, you fit them, and that's it. You fit and forget. They'll last the rest of the life of the engine. So yeah, I think so. With good studs and with a good head gasket, you know, head gasket issues are sort of eliminated with Bristol engines.
Can I say thank you very much for a remarkable and erudite talk and fabulous.
And over lunch, feel free to poke and prod all of these things sat on here. Have a good look, turn them upside down. Yeah.
Our sandwiches are waiting out there for us, and fruit and various things. Tea and coffee is available here, free. And let's continue to the banter and erudite technical discussions over lunch. And we'll kick off again, I don't know, 2 o'clock, something like that. So, bravo.